Okay, so here we are again. We're making bioplastic, and what I've done here today is I took my piece of silk, and I wanted to be able to cut it so that it's got, like smooth edges and stuff, and I'm going to measure it and, fit it to my piece of biological plastic here. It looks like a piece of cardboard because that's what it is, but it's now, as you can see, plastic. And I've got a little bit of silk on here, and you can't even hardly see it anymore. Look at that. When I get a few more coats of shellac on, you won't be able to see it at all. Um, and so what I'm going to do is, this is, a little tacky. I just put it on about a half an hour ago, or an hour, something like that. And that's the way to do it. This, when you get a piece of silk that doesn't have clean edges, it's really, really, really fine threads, and it frays, and it's really hard to cut because it's so flexible and thin. So, and I wanted nice, clean edges. So I took, that bioplastic called Elmer's glue. Just plain old Elmer's glue. And I rubbed it all over my piece of silk here. And now it's got a little body to it, okay? And I can cut it. I can cut it nice and straight and even, and the silk is going to stick to the shellac better. This part here was not dipped in. This part was, and that part was. This part was just alcohol and shellac. This part was alcohol, acetone, and shellac. And I've got a little tester here. Hang on. I see. I was opening it upside down. I knew I was doing something wrong. Okay. Anyway, here it is. A little tester that tests the hardness of plastic. And this is wet. I don't want to get it on my nice machine here. But when I tested it, I also tested this right here. And it's nice and easy. You just take it and press down. So 56. My bioplastic here with two coats of shellac was 80. 80. This, I don't know what the HA scale is or what it means, but I tested it against known plastics. Plastic is usually the same hardness as our fingernail, about 2.5 on the Mohs scale of hardness. Okay, so that will give you a little clue. The softest mineral is called talc, and it's also called soapstone, and you can scratch it with your fingernail. Wood is about 3 on the Mohs scale of hardness. So is copper. Stainless steel is 5.5. This, when I get done with it, should be around 5.5 with covalent bonds. with covalent bonds. And what I'm going to do next is add some AUPT to my shellac, which I have not done up until now. And I should probably put the top back on. These are really handy for that kind of thing. I don't know if you happen to have a top that's not shellac to the lid, to the screw part. Okay, so, and I use these things all the time, these mason jars. They are real handy. Okay, so what I'm going to do is add some AUPT dust, just a pinch to this. Maybe more than a pinch, maybe quarter of a gram, something like that. It doesn't take much, and I'm not using much, right? I'm not using much, so so when I put the silk on, it's going to have this wetter or moister shellac. It takes a day or so for it to dry, and the silk with the Elmer's glue in it sticks to it real well. And then I'll just, paint on some more shellac, and there we have it. The shellac seems to be changing its consistency. When I first made it and I put it on my brush, it came right off. It just dissolved right off. Now it's been sitting there for a while, and I added some acetone to this one. So it's the acetone harder one. The harder one was this one at 80, and this one was about 75 or 74. Not much difference, really. But enough, a few degrees is enough. So what I'm going to have is a layer of silk that's kind of got a little rubbery feel to it. So it's got a little more stick-to-itiveness, not just sticking to this, but sticking to itself, which is why I can cut it. So we're going to cover this. Now, I bent this after the first layer. I wanted to see if it would retain its shape, and it didn't. I worked with it a little bit, just trying to bend it back, and to see what would happen, and it's almost as rigid as steel. This is a little bit weaker than this side. This side I can't do more than, look at that. That's a piece of cardboard, and I'm pushing. I've got strong hands. And it is not bending. It weighs about a gram or something like that, maybe 2. The whole thing. Maybe not even that much, I don't know. So, if I have the wing of my airplane made out of this, with silk and all of that, it's not going to weigh very much. I'm aiming at 10 meters right now, okay, 30 feet. And I can make wings. It's going to have more than one layer, and it will have silk in between them, laminated, and it will be lighter than a cork. This is all still lighter than a cork. If you take a wine cork out of a wine bottle and you weigh that versus this, right, 10 centimeters by maybe 18, I don't know, 20, something like that. 20 probably. And listen to this. It's almost as hard as the wood. It's almost as hard as wood, and when I get the silk on it and a couple more layers of shellac, I'm going to put it in the oven, and it's going to go past wood to about the same hardness as maybe aluminum, and maybe one day stainless steel. We'll go for the aluminum right now. About 4, I think, something like that. So there it is, bioplastic, and it's available at every hardware store in the world. I buy dry shellac flakes, and this is garnet red. And when I'm done, I'm going to have almost a candy apple red on this piece of cardboard. See how that is in the crack there? Yeah, pretty cool. So I will check back and we will show you the progress.